Hey everyone, and welcome. So today we're going to talk about a wild 150-year-old economic idea that is suddenly the talk of the town in tech. I mean, we're hearing it from Microsoft's CEO all the way down the line. It's called the Jevons Paradox, and it basically takes everything we think we know about efficiency and flips it completely upside down.
All right, let's just jump right in with a question that's going to sound, well, totally backwards. What if every single time we get better and more efficient at using something, we actually end up consuming way more of it, not less? It sounds crazy, I know. But as you're about to see, it happens all the time.
So first up, we've got to tackle a myth that pretty much all of us believe. I like to call it the efficiency myth.
You know the thinking. It's just common sense, right? If you make a car that gets twice the miles per gallon, you'll use half the gas. If you invent a super efficient light bulb, your electricity bill will plummet. Simple, straightforward, logical. Well, the real story is a whole lot messier.
And that story really kicks off way back in the 19th century, thanks to a really sharp observation by an English economist.
Picture this, it's 1865. Steam engines get this massive upgrade, making them way more efficient at burning coal. So this guy, William Stanley Jevons, he expected Britain's coal use to go down, but the exact opposite happened. It exploded. The more efficient engines didn't save coal, they basically threw gasoline on the fire of the Industrial Revolution, leading to more factories, more trains, and a crazy increase in total coal consumption.
And that, my friends, is the Jevons Paradox in a nutshell. The theory is that when technology makes a resource cheaper and easier to use, demand for it doesn't just stay flat. It often shoots up so much that it totally cancels out and even surpasses the savings from the efficiency gain. This is sometimes called the rebound effect.
So why on earth does this happen? Well, it's kind of a perfect storm. First, something gets cheaper. So yeah, naturally we want to use more of it. That also makes it accessible to way more people. But here's the real kicker. People start inventing brand new ways to use it, things nobody even thought of before. And all that new activity just fuels this massive economic boom.
Now you might be thinking, okay, that's cool for steam engines, but what does that have to do with my smartphone? Well, let me tell you, this paradox is alive and kicking, and it's everywhere in our modern world. Just look at these two examples. We thought fuel-efficient cars would mean we'd use way less gasoline, but what did we actually do? Well, driving got cheaper, so we drove more, bought bigger cars, and lived further from work. Any savings? Poof, gone. Same story with LED lights. They're insanely efficient, but now lighting is so cheap that we're putting them everywhere, lighting up our buildings, our streets, our gardens, which has led to a rise in total electricity used for lighting.
And this brings us to the big one, the main event, artificial intelligence. This is why tech leaders are suddenly dusting off this 150-year-old economic idea, because AI is poised to put the Jevons Paradox on steroids.
This table just nails the feedback loop we're seeing. Every time we find a way to make AI computing cheaper or more efficient, we don't just run the same old programs for less money. Oh no. We build vastly bigger AI models and invent entirely new applications that were unthinkable before. And the result is an explosion in demand that just dwarfs the efficiency gains, leading to way higher total energy use.
See, the key thing to get here is that AI is creating an abundance of something that used to be scarce, cognitive work. Stuff like writing, coding, or analyzing data. A tool like GitHub Copilot, for example, doesn't just help a developer write the same code faster. It enables them to generate so much more code that they can take on projects that were completely out of reach just a few years ago. And if you want a jaw-dropping example of this, here it is. Modernizing old clunky COBOL code used to cost a fortune, like 20 bucks a line, so companies just didn't do it. But now AI can slash that cost down to maybe just $2 a line. Suddenly, an impossibly expensive task becomes totally doable, potentially creating a brand new $1.6 trillion market. That's not saving costs, that's creating a whole new economy.
So what about our jobs? Let's talk about radiologists. The initial fear was AI will learn to read X-rays and all the radiologists will be out of work. But the reality that's playing out is way more interesting. AI makes medical imaging cheaper and faster. So what happens? Doctors order more scans, and that means we need more human radiologists to look at the really complex cases and make the final diagnosis. The job is evolving, but the demand is actually growing.
But, and this is a huge but, this transition comes with a real risk. A lot of people in tech are talking about the boiling frog metaphor. You know the one, if you put a frog in water and heat it up slowly, it won't notice the danger until it's too late. That's the warning. If we're not paying attention to how AI is slowly changing the nature of our work, we might not adapt in time. The skills that make you great today
might not be the ones you need tomorrow.
So this all sounds a bit daunting, right? If just being more efficient can backfire, what are we supposed to do? We obviously can't stop innovation. The real challenge is figuring out how to manage this rebound effect.
And this right here, this is maybe the most important takeaway of all. Making our technology better is absolutely essential. We have to do it. But it is not a silver bullet. On its own, it's not going to solve our massive challenges like energy consumption or climate change.
To really get a handle on this, we need to attack it from all sides. We need a three-pronged approach that combines smart government policy, proactive corporate strategies, and real changes in how we actually build and use technology.
First up, smart policy. This is about creating rules that reward true sustainability. Think of things like carbon taxes, which put a real price on pollution, or even setting absolute caps on energy use or emissions. These policies create a framework that guides all that new innovation in a more sustainable direction.
Next, corporations have to start thinking differently. It's not enough to just brag about your efficiency metrics. Companies need to be held accountable for their total energy consumption, the absolute number of kilowatt hours they burn each year. Some are even implementing internal carbon pricing to make their own teams feel the real cost of their compute usage.
And finally, it comes down to the people building this stuff, the architects and engineers. This is about building smarter from the ground up. It means writing code that isn't wasteful, using architectures like serverless that only use resources when they're truly needed, and investing in advanced physical tech like liquid cooling for data centers.
So we end up right back where we started, with this incredible paradox. AI and all this amazing tech promise to create a world of abundance. But the Jevons Paradox is like a little warning label on that promise. It reminds us that abundance always comes with a hidden cost. And so the ultimate question isn't really about our technology, it's about us. Can we find the wisdom to manage that abundance responsibly? Thanks for watching.